Hi, welcome to the next channel. So I was going through ZFS stack, the open ZFS stack in general, both the FreeNAS as well as Ubuntu Linux source code, and I was going through the ZIL part of the modules inside the source code, and while going through the same, I thought let me go through the VDEV modules because it contains some interesting APIs. So this video, although I'm doing some kind of source code walk, I thought this will be quite interesting in case if you're a systems admin or a network admin, in case if you're setting up any storage server or a NAS with FreeNAS or any type of ZFS based system, because although you don't do coding, you can understand its internals. I have discussed a couple of them in my earlier episodes, like how the compression modules are coded in the OpenZFS stack, and as well as various initialization aspects of OpenZFS file system source code actually. So as a part of that, if you hop on here, this is the source code of FreeNAS versus this one is the source code. You get it from custom Linux build. This I pulled via my Ubuntu server. And if you pull the source code of Ubuntu server kernel source, it also pulls this ZFS folder. So you can see here, it is within this folder Ubuntu Bionic, and within that you get this ZFS. Since it is not packaged as a part of your standard Linux kernel source due to the license differences, that Linux comes with the GPL v2 versus the ZFS, OpenZFS is released by Oracle with the CDDL license. So due to that, they can't bundle the same as a default file system, as a one among the file systems by default within that Linux kernel source, but you get a sort of this type of source code when you pull the kernel source of any Ubuntu server. So when you pull the kernel source in Ubuntu server through apt-get or apt source Linux, what it happens is it pulls the kernel source. It does like a git pull from kernel.org, and then once it pulls the same, it does patch of any Ubuntu specific modules. You can also see there is a folder called Ubuntu. Of course, you can't find this in a standard Linux kernel source, so it also gets all the patches, and then it patches them, and then it presents you the patched tarball of that kernel source. So as a part of that, you can find even the ZFS stack as well. So that is the reason you can't find this in standard kernel release. So if you hop on either in this sources or else in FreeBSD based FreeNAS sources, you can find an interesting file like VDEV, as I mentioned before. So in this there are some interesting APIs which deals your overall VDEV part of ZFS pool. So you can see here there is some documentation. Of course, you can go through the same, and there are some interesting APIs I thought to discuss. See, there are certain APIs, they have mentioned the basic operations of VDEV ops. So these ops are like you have a file system or a network stack or something. This is like various ops or operations possible for that particular stack. It can be even device drivers also. So in general, they record these operations. See, you should understand this video, I want to focus more on a way where even a network admin who is not into development can understand this, so that he can customize his server based on whatever it happens internally. So you don't need to rely extensive on either FreeNAS documentation or any other open ZFS or any documentation, because you get a knack of understanding this source code to an extent. So based on that, you can fine tune your server as well. But besides, if you are a developer, of course, you can understand what I'm saying, because one or other day, if you are interested, you can directly touch this code and you can do your changes. So you can see here it has operations registered over here in this table or the data structure. And if you go down, there are some interesting APIs which caught my attention. So that's the actual intent of shooting this episode. So if I walk down, you can find some few APIs. So let us just go down. Yeah, you have this VDEV alloc. This is quite interesting, and besides there are some init APIs, and of course you have this VDEV free, which is opposite of VDEV alloc. So anytime if you get alloc or free, these are like your malloc and free, or in case of networking you have skb alloc, skb free and stuff like that. So it creates a new instance, and when you do a free, it has to do a graceful free of that. So when you do an alloc, so based on that it has to load into the memory, and it will occupy the memory resources and stuff like that. So when you do, of course, free, it will clean that area, or it will free the memory space. So these are APIs which are generally will be used in any type of stack operations. So if there is some sort of dynamic data structure or something which is initialized, and it needs a sort of memory instance actually. So these are a couple of APIs. You can see here it is taking this VDEV_T data type. It may be some struct. You can find those structs in some include path here. So somewhere if you go through, you can actually find its header file. So let's not much go into that. Let's assume it is some data structure defined somewhere actually. So in a couple of previous episodes I have even discussed about a couple of those header files as well. So anyway, in this episode we just focus on this APIs, because this gives a sort of a flow how this stack gets initialized, and based on that you can go through various internals, and also in case if there are any specific defaults, how it is fine-tuned, and based on that you can customize your system resources as well. I mean to say your hardware resources, or any sort of tune up if your device can be done, and from that you can get some type of performance improvements and stuff like that. So moving on, you can see VDEV top transfer top level VDEV state from SVD to TVD. I'm not sure what it is actually doing, so let's just hop on to other set of APIs. You have something called VDEV add parent and other stuff, so let's not get into it. Probe done, VDEV probe. Yeah, here it is an interesting API. See here it says determine whether this device is accessible. So sometimes if you have any metadata corruption or sometimes and of course this is the reason even IX system recommends you to use ECC memory, because when it is loaded onto the memory, if there is any sort of rogue corruption or something in that memory, then what happens is, if it is not ECC, it is getting undetected, and it may corrupt that metadata which is real time, and it is loaded onto the RAM. So in that case it has to see that anything it is changed, and in this case it is also doing some type of device level check. So it may be even IO possible operation, not just memory metadata check alone. Okay, so that is what I don't want to go much in depth, because it gives the sort of overall big picture. So that's what is the intent of this episode. So other than that, if you go down, you have some important ones like this VDEV open. See, you can see here prepare a virtual device for access. So this is a quite important API. Within this API it is calling many internal APIs within the same. So let's not go again much in depth. So VDEV set state and stuff like that, it is doing several operations within the same. And below again one more API which caught my attention. You can see here this API is quite interesting. It's called as VDEV validate. This is I think it has to do some type of validation of your VDEV pool, and below that is another important API I found. If you little scroll down, it will say that in this case it is a VDEV close. So this is also an interesting API. It's about closing the device. So somewhere you can find this will call internally that VDEV alloc and free respectively. When you do open inside, it may do an alloc operation, and free it may do any close operation. It may do any VDEV free or some kind of operation, because memory allocation and close, always it happens within that device open and close operation. So in this case it's not a device, it's like a file system initialization, the data structure and the APIs, it is trying to initialize the same. So in this case it is trying to when you open it, it does that allocation part within that. When you do a closure, it does that freeing the resources and stuff like that within the same. So this is something a generic hierarchy. If you are not into development, this may be new to you, but if you are a programmer, you may be already well aware of that, because in the kernel source you can find many such examples, whether it is device drivers or network subsystems, network protocol stack, or else even in the case of file system, subsystems and various file systems, all have this type of approach. Okay, so that's what. Somewhere you can find the same, and below that you have this resilver. So you have this VDEV create and stuff. But if you little bit scroll down, I want to take you to this API. There's an API called resilver, and it also tells whether the resilvering is required or what actually. So let's do a search. Yeah, you can see here. Yeah, you can see here. This is the API, and this caught my attention because you see here, determine if resilver is needed, if so the TXT range and something. So again, I'm not any expert in ZFS. I'm just started getting into the same, and I need to explore lot of the source code. I need to put lot of debug, and I need to understand the actual flow of the source code. But I thought let me cover so far whatever I have done the code walk as a part of these episodes. So you can see here, this is an interesting API, and one thing you can do is, even if you are not into coding, if you are just an admin, you can generally go through the source code like that, and you can find its hierarchy, where it is getting called, in which case it is getting called. So this gives a hint when this API gets called, and of course we do resilvering when you add a new drive to the, or you replace a drive, failed drive in your ZFS pool, and at the same time, in case if you do any scrub operations, maybe it may call this API down the lane. Okay, maybe it may have a top API meant to do scrub, and within that it may do this API. Who knows actually? So that's what you need to see, the hierarchy wherever it is getting called. See, you can see here it is getting called over here. See, previous instance it has called within itself like a sort of recursive operation, and if you further search, you can see it has been called over here, and we need to see in which API it is getting called. Yeah, you can see here it is calling in this VDEV open. So one can understand, as I said, VDEV open can do this initialization. It may also do some memory resource allocation, and then in case if it finds any sort of discrepancy, it may even do this resolver required or needed API. So you can see here within the same, it is calling the same. You can find any documentation at which circumstance it may trigger this API call. So this is what, as a system admin, you can actually trace, because your intent is not about changing the code, writing a new code, but you can see that if you are passionate about the same, you can go through the same, and maybe it may be a good learning standpoint as well. So that's what. The reason I'm saying is, I'm getting these days a lot of queries from various FreeNAS enthusiasts, as well as I mean, the moment I started the series on NAS OS and going much deeper episode after episode, I'm getting queries from systems admins mostly across the world. They have their ZFS setup, they have their own install, they are confused about certain aspects. So sometimes they freely ask about certain tips and suggestions in a systems level. So as a part of that, even the recent episode I have covered about ditching FreeNAS. There is a user, FreeNAS user, who mentioned that he's going to transition or migrate from FreeNAS to Synology or something like that, and I was giving some feedback about how to use your FreeNAS OS boot device, because in that video many have commented that they are having similar issues with yeah, you can go here, you can see here, this is the video. So in that video, many users have commented that they are also facing issues with the FreeNAS USB install, but I mentioned that one should always keep in mind that any USB drive is not meant for 247 usage. You have to use it quite cautiously. So the video I was trying to give certain tips and also a sort of feedback, and I'm fine with the user's decision to ditch FreeNAS and go with Synology, because sometimes it's also a good reason to go with, because you need to you don't need to much spend your time in terms of getting your custom hardware resources and building your own, in case if you're not that comfortable and not interested. It's perfectly fine to use any ready to use hardware. There is nothing wrong in that. And also, of course, you pay some premium for their inbuilt software, whatever it is done exclusively for that hardware product range or series. So that's fine. But in case if you are a network admin, if you are already using it and you have faced some issues, being a systems architect, I felt let me give some tips and tricks so that you can avoid certain aspects. And also it's just not about ECC or NAS drives. There are other aspects which is far more dangerous than that, and you need to sort of focus on those aspects as well. So again, as I mentioned in all this NAS OS, I'm not using any NAS drives also. So, and in my case, since I'm not powering it on for 247, I'm fine to use any consumer grade hardware, and moreover it is going to sit next to me, and I'm going to supervise all the time as long as it is powered on. So I don't have to worry about it is remotely connected and whether I get connectivity or not when I'm not at home or something, or maybe small office, whatever situation it is. So I don't have such criteria. I'm perfectly fine to use any consumer grade hardware in my situation. So in my use case, it may work perfectly fine even for 5 to 6 years straight, because it all boils down how do you use your system resources, and there is not much of wear and tear going on in my aspect. So it is perfectly fine, but it may not suit in your situation. So keep these aspects in mind. At the same time, if you are a little bit passionate or enthusiastic about understanding the same, you can go through the source code. As I mentioned, there are some subtle differences you can find between each source code variant you can get from OpenZFS as it is, or you can get through this way, or you can get through FreeNAS source. You will get some subtle differences. If you go to this table itself, you can see there is a subtle difference between this and that actually. Okay, let's go to the ops table. Yeah, if you go to this table, you can see here if it is kernel so and so, they added some conditional formatting, versus here it's a Ubuntu source. You don't have that sort of stuff happening. So you will find some changes here and there, and of course they may do some bug fixing, they may do some performance improvements, they may do also something which is more to do some fine tuning with FreeBSD OS, since FreeNAS is FreeBSD based, versus they may not do those things in the Linux variant of ZFS stack. So these are the aspects, and end of the day it doesn't matter which operating system you use. It only matters how the OpenZFS source is taken and how it is fine tuned. So that's what ultimately it matters. So that's why you need to see all these subtle changes. It's not that something is working better in FreeNAS and something differs in Ubuntu, or else just like that you migrate from ZFS spools from one OS to other OS. So sometimes they may do some fine tuning and stuff like that. So it may drastically change the performance, and sometimes something may work well in terms of performance, but in terms of stability and robustness it may lack. So you need to be very careful about choosing your sources in that way. So many things are possible. As just a user of or a consumer, you may not be aware of all these tweaks, but these things are very much done, and that is why you have a release after release. So they may address system level bugs and as well as UI level and the OS level or the package level bugs as well. I mean to say the distro, the FreeBSD's variant, or else even the FreeNAS variant, the distro level features and bugs as well. So these things are all possible. So you need to keep that aspects in the mind. It's just not just OS you change and then you get higher performance and you decide something based on that. So there are so many things also it requires. When it comes about reliability and robustness, you need to take all these factors into consideration. Don't go just behind the performance alone. Sometimes it is all about reliability, and as we know, FreeNAS is a lot more, it actively checks, validates your data, and in case any discrepancy, it heals itself. And as I mentioned in the previous episode, it is highly CPU and memory intensive. You can't escape out of it. Okay, so that's what. So in case if you are looking for any tips, or in case if you are looking for any guidance or assistance, be in touch via mail, or you can discuss via YouTube comments. And in case if you are looking for something which I know, I can answer directly. If I don't know, I may need to go through the source code and I can answer the same, and I can also pinpoint the line number or the API within the source code, so that you can also have a check. You don't need to be a programmer, but you can have a check. You can read the documentation, the comments, whatever it is, and you will get a fair idea about the same, and then you can take a decision based on the same. So in case if you like series like this, hit the like button. Thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.